Hi campers, I'm Dave Woodring, and I'm here to talk a little bit about dendrology, which is just kind of a fancy name for study of trees. And at Camp Canopy we'd be looking at about 20 of them, but we don't have that much time here today, so I've got just a little handful to show you. We'll be looking at, well, there'll be the maples, the ash, and the dogwood, and the last one will be a buckeye. But before we see the leaves, I'd like to take a minute on the chart here and look at a twig. This is how a typical twig would look in the winter time. The leaves are gone, but notice if this was in the winter, next year's leaves, next spring's leaves would already be on there. And you can see them here. The ones on the side are lateral buds, and the leaves are inside there. They're not fully formed, but they're there. And there's one on the end called the terminal bud, and it is in those buds where the new twigs and the new leaves will grow from. And when we show you leaves at Camp Canopy, we always have the twigs with them. We always show the leaves attached so you can see how they are attached. And these four or five that I'm going to show you all have something in common in that regard. They are all attached, all the leaves and the twigs too, attach in a opposite way, as is shown in this picture. That's unusual in nature. Most trees here in Ohio and around the eastern United States will show this pattern, which is alternate. So out of the well over 100 trees we'd have to see here in Ohio, practically all of them will be this way. There is one that's different from both. There's one that has three leaves together we call whorled. The only one I know of that does that is the catalpa. And I did have one, a little one, till last winter, and Bambi ate it, so I don't have that one to show you. But I do have the opposite, so we'll take a look at those, beginning with the maples. And this here is the sugar maple. We do test two maples at the Camp Canopy. We do the sugar maple and the red maple. But all the maples, all the species, will have that opposite arrangement as you saw on the chart. This one's missing one on the other side, but there should have been one there. Two little ones here show the opposite arrangement. These two at the end, near the end. And finally these two. The leaves themselves on the new shoots, you can see with a close-up, you can see that those leaves come out from the twig opposite each other, like the arms coming out of your shoulders. Now this is the sugar maple, and the way we tell that one is that right in the leaf where between the points, maples have several points, but sugar maple has three main big points. In between the points where they meet is a place we call the sinus, and it forms, maybe you can see it a little better on the bottom, it forms the letter U. And that helps us because there's a U in sugar. The other maple I have to show you, again, shows that opposite arrangement that all maples have. These are last year's twigs here, as you saw before. And the ones that are green are this year's growth. In fact, everything you see on this that's green grew this spring so far from a bud. The leaves and the new shoot coming out. The new shoot here and here. Now this is the red maple. On this one, the leaf stems happen to be red, which is convenient, but that doesn't always hold true, so we can't really go by that to distinguish this one from the sugar maple. But what we can do is look at the same place where we looked on the sugar maple, and that is where the points come together. And there you see, instead of a U, we have a letter V. Now unfortunately, nature didn't cooperate here because there's no V in red. but there is a V in Valentine, and Valentines are red. So if that helps, that's the red maple. This one also has seeds, and it didn't take very long. It's just only been out a couple of weeks, and there are seeds fairly well developed already. Interestingly enough, the seeds on maples are also in twin pairs, like the leaves. The next tree we have that has this opposite arrangement is the ash, and I had to look around a little bit to find a live one. Because of the emerald ash borer, the EAB, ash has really taken a hit, and I don't have very many living ones left on the property. But I was able to find this one, and you see these shoots. All this green has grown this spring yet. There's been a lot of growth out there. Opposite branches, opposite leaves. Now with the ash, we're coming on to something a little bit different. I'm going to take one of the shoots off so we can see it more closely. The ash leaf is divided. One would think that this is a leaf, this is a leaf, this is a leaf. Actually, these are leaflets. And the entire thing is one leaf. How do we know? Because at the base of the leaf, you'd have to look really close because this is early in the year, but there's a little bump there. And that's a bud. And there will always be a bud growing at the base of the leaf. So the ash leaf is divided into several parts. We can see that on this side of the chart. If we look at right here, we see most leaves are what we call simple. They have one wide part, one skinny part, like the maple had. The wide part is called the blade. That could be the palm of your hand. And the skinnier part, like my wrist, would be the leaf stem. We prefer to call that the leaf petiole, though, so that we don't confuse this with the actual stem, which is made of wood. So we say the simple leaf has one blade, one petiole. This one is divided, so we call it compound. Compound meaning it has more than one, and that would be the ash leaf. Hickory leaves do this also, and walnuts and several others. That would look, if that's not an ash, it looks pretty much like my guess it's probably a hickory, but it has that same basic structure of a divided leaf. The third one to look at that has opposite branches is the dogwood. And of course we call it the flowering dogwood because it has these nice beautiful flowers, although we should remember that all trees have flowers even though they don't show like the dogwood does. But here's the opposite arrangement. You can see on the branches, on the smaller twigs, and out even toward the end you can see that the leaves themselves are in opposite pairs. So that's 3 out of the 4 that we'll see. I guess 4 already, including the 2 maples, but we're looking at 4 actual groups. The maples, the ashes, the dogwoods, and finally we'll take a look at the buckeye. This is my one and only buckeye tree on the place. I planted this from a little buckeye about, well, I think it's been 4 years, maybe 5 now, and it's really taken off this year, looking real good. But I didn't want to take a leaf off because it's so small. But this is the buckeye, and it has the opposite arrangement as we saw earlier. Here's the new growth. See, it's all green, the new growth is green, and here are the opposite leaves. Now, buckeye, like ash, is compound, although it's a little bit different because in this case, where the ash had leaflets coming out along a leaf stem, the buckeye's leaflets all come out from one point, like the palm of your hand. So we call it palmate. palmate compound. And those are the only four groups of trees in Ohio that have opposite leaves. And if we take the first letter out of those four groups, we have M for maple, A for ash, D for dogwood, and buck for buckeye, gives us MADBuck. And if you can picture in your mind's eye a MADBuck, it's just a little memory trick to help you remember. Anything else you see in Ohio, other than the MADBuck group, will have alternate leaves. Hey campers, good to see you. I got a little follow-up for you on how trees grow. You know, trees don't get around much, but nonetheless, they live a pretty busy life. They grow all their life. They never stop growing as long as they live, and they reproduce. Speaking of growth, they grow basically in two directions. They grow out and they grow up. Of course, they grow down too, so I guess three directions all told. I'd like to look at how they grow in diameter first. Most people know, of course, that there's a ring for each year. We call them annual rings because there's one ring produced each year. And that ring is produced by a very thin layer of growing cells called the cambium. You can't see it with the unaided eye, but it would be right here. It's pretty close to the outside. The life of the tree is not down inside. It's right toward the outside. And the cambium is the actual living tissue that produces the rings. So as each additional ring is added, that cambium layer gets a little bit bigger to accommodate the increasing diameter of the tree trunk. And the same is true for every limb. That cambium is like an envelope that covers the entire tree, from the tiniest root under the ground to the tiniest twig at the top of the tree. So those are the living cells, the cambium layer. They are located right between the last ring produced, which would be last year's ring, and the bark. Now everybody knows, of course, that trees have bark. Not everybody knows that they have two kinds. And you can see it on this large cross-section here. The outer bark is kind of a light brown color. That's basically like the skin of the tree. It's not living tissue. It protects the tree from cold in the wintertime and from insects and fungi. So it's kind of like our skin. But underneath that outer bark is another layer of bark, much thinner. It's a slightly different color. It has a little bit of an olive green cast to it. It's about 1/8 of an inch thick on this cross section. It's right here. And that is the inner bark. And that is actually conductive tissue. And what it does is it brings sugar water, sugar made in the leaves through photosynthesis, travels down through that inner bark all the way to the roots. And that brings food energy throughout all the growing tissue of the plant. And conveniently, that sugar water that comes down through the inner bark is right next to the cambium, which is the living part, and has to be sustained by that sugar. So each year, one additional ring is produced, and that's why we have an increasing diameter, and that accounts for diameter growth in the trunk. Incidentally, on the outside, as the cambium is producing a new layer of wood on the inside face, at the same time it's producing a new layer of bark on its outside face. So you have rings of bark as well as rings of wood. They're a lot thinner and they're hard to see, but under magnification you could count the rings of the bark just like you can count the rings on the wood. So that is a kind of how the tree grows in diameter in a nutshell. Now, while it's growing in diameter, the tree also grows in length, and that can best be seen by looking at a twig. Now this is cut from a hickory tree. I cut it a couple of weeks ago before the leaves came out, so we could see the buds and we could see the leaf scars, as I briefly mentioned the other day on our tree ID segment. But what I've done on this is I have marked out the years of growth as they've occurred on this stem. And to begin describing that, I need to point out the bud. This would be the terminal bud right here, and there are lateral buds as we go down the stem. But starting at the terminal bud, this would have been this year's leaves. If I had left this on the tree, this would have opened, and it would be green, new growth now. Now, when the bud opens, notice there are scales on that bud. When the bud opens, those scales fall off. When they do, they'll leave a scar. And that scar can be seen for each year that has taken place. So, from right here where I marked in red is how much this tree grew last year. So I marked it 2019. 1 year ago, there would have been a terminal bud like this right here. When it opened up, it would have left a scar. And I've outlined that scar in red right there. That's last year's terminal bud scale scar. So because of that, it enables us to tell how far that tree grew in length for that year. In 2018, same way. There's a terminal bud scale scar here and another one down here. So in 2018, this twig grew this much. 2017, for whatever reason, it only grew about maybe 2 inches. It's not the same for year to year, depending on environmental conditions. 2017 was this much here. And the same for each year. 2016, 15 was a good year. Went from here to here. 2014, 13, 12, 11, and 10, 2010. So there, from here to the tip, represents 10 years of length growth for this twig. And the same would have been taking place on every twig on this tree, including the very top. Notice as it grew, it also, as each consecutive year grew, the year previous became one year larger in diameter. So out here, the 2019 segment only has 1 ring in it, so it's very thin. The 2010 segment down here is much thicker because it has 10 rings inside, just like in the cross section. Just like in the main trunk, each twig puts forth 1 new ring each year. So there we have diameter growth and length growth. The cambium goes all the way up this twig. It's smaller and smaller until it gets to the very end and it meets at the living tissue inside the bud. So the life of the tree is all connected. The cambium tissue in the trunk and the roots and out through the twig is all one connected life force in the tree. Diameter growth and length growth.